Welcome to the 7th episode of the TikTok podcast, where we focus on software engineering and how to become a better engineer. Today, we have Geshan who is a lead software engineer at the Iconic. And we'll be talking about software engineering and microservices and a lot of things around it. So, welcome to the show, Geshan.
Thank you, Ravi. Thank you for the invitation. It's good being here.
So, Geshan Dai is someone who we have met few times in the community events and everything, but we haven't like actually worked together. But following his blogs and everything, like I know he's a very technically savvy person, and he used to work in other countries before moving to Australia. So I just wanted to cover a little bit about like how is your role as a lead software engineer at the Iconic, and like what do you do on a daily basis. So could you please share that experience with us?
Sure. Yep. So I have been working in software engineering for probably around 14, 15 years by now. And yeah, I have been on Australia for the past almost 3 years. I think it's going to be 3 years pretty soon. As a lead software engineer, I became a lead less than a year ago. So before that, I was a senior software engineer here at the Iconic. And that was like being a senior software engineer, people might think it's like 90 or 95% coding, but it's not that. There is a lot of coding involved, but it's a lot of more communication and other people skills that you need in being a software engineer. And especially after being a lead software engineer, that balance again goes out. Like you code less, and then you have a lot of more meetings. These days it's what everyone is talking about, the Zoom fatigue, as well as a lot of communication, a lot of coordination, and all these things go into the mix. So yeah, it is some coding, of course, yes, as a lead software engineer. But yes, with that, there comes a lot of communication, coordination, and as I said, a lot of people skills involved in that. So yeah, I would say in the past 8 or 10 years, yes, it's been some coding as well as all of these people level things and communication, which has been part of my job.
Okay. So I think a big part of our job responsibility would be to like make sure that the code and everything is written properly, and like you probably also review codes and everything, right? So in terms of usually when we talk about coding and reviewing code, like as a software engineer, we talk about writing clean code, and clean code is something that's been in around for a very long time, but like it's a topic that is not it's confusing for so many people. So could you please like explain your experience on like what exactly is a clean code, and like what defines a clean code, and like how do you actually work with that philosophy?
Sure. Your question actually touched upon two things, so I'll go into them one by one. First thing, I think what you touched upon is the code review part, right? So for the code review, it's easy to get into minor things. For instance, the spacing, the commas, and the brackets, and these kinds of things. Rather than that, it's always good to ask, why do we need this code in the first place? There is a quote, I forgot where I read it, that said like deleted code is the best code, or like code that's never written is the best code. So if you can solve it without code, that's one of the best ways to solve any problems. Because I or like generally what software engineers should do is they should consider themselves as solution providers, and code is one medium of actually providing that solution. I don't know, like one other medium. For instance, if you need to do something, and what you could do without writing code could be adding another Google Chrome plugin that just does the same thing. That's also a solution. So code review, yes, it has to be thorough. You have to actually go and read through the code. But yes, the first question you need to ask is, why do we have this code in the first place? And then the how and what and these things come into the picture. That's the code review part of it. Okay, coming to clean code. So the clean code, the word clean code, I think comes from a book. I forgot who wrote it. I should have remembered it, but anyhow, it comes from that book, and then it has a lot of prescriptions from that book. But how I would understand clean code is basically the first question I would ask at looking at a code, a class, a method, or even a variable name is it maintainable? Because that's one of the things. Sometimes it is a bit difficult to strike the balance between maintenance and performance, depending upon which language, framework, blah, blah, blah you are talking about. But the first question to ask is it maintainable? So basically, clean code easily equates to not writing very long functions, writing things properly, naming it properly. And as another great quote goes, there are only two difficult things in computers. One is naming things, and the other one is the cache lifetime. So basically, if you get these two things right, most of the things are good. So yeah, if I had to look at things of clean code, I would say shorter things, testable things, and then tested things, a relatively good amount of code coverage and testing depending upon how you evaluate code coverage itself. So those would be like the main things that I look into. And then depending upon the team, the context, like it depends upon many things. Like depending upon the team and context, like things into going into design patterns and these things might be considered. But I think the main question to ask regarding clean code is, as soon as you see something, is it maintainable? If I come back to this same code after 6 months that I have written, will I understand it? Why did I write it? So those will be like the main questions I ask, because many a times what happened is like I am looking at a piece of code, and then I start probably shouting at the code or even cussing the code, saying, who wrote this? And then I look at the GitHub blame, and then it's me. Like after 8 months, your own code becomes alien to you. So that's why, like any other code that you review or that you see, the first question you need to ask is it maintainable? Like a very good measure of it is 6 months down the line, you don't remember your code. So will you understand this particular method or this function or this class if you read it like 6 or 8 months in future? If your answer is yes, then it's generally maintainable. That's like a very easy yardstick or a baseline that you can follow to know that how maintainable your code is. Of course, if you go into the other details of things like design patterns, blah this and blah that, there are rules, there are laws related to code. So yeah, you could read out all of that, but at the end of it, it's writing smaller things, testable things, having a good mentality to test things, possibly starting with unit test, and that's basically maintainable code in a nutshell for me.
Yeah, so the major takeaway from this would be probably, like, it's not about the spacing, it's not about using a tab versus spaces and like commas and semicolons. Like, it's about how maintainable and testable your code is, as in like how smaller chunks of code as you can write is more maintainable and everything. So it's around the philosophy of that, right? But usually I have found out that many companies where senior engineers actually go into and like they start taking details, nitty-gritty details of the code, and like say, hey, the variable name it should be this, like why you're writing that, right? The semicolon and everything. So I have been into that type of team leads as well. So but that is something it really depends upon team, I believe.
Just to add upon it, for instance, that these commas, variable spaces, and these things, what I think is, whatever can be automated, just automate it. Like, agree on a standard, agree on a linter or something, keep it there, put it part of your CI. If it doesn't even pass your CI, don't even go and review the code. Whenever a human needs to look at the code, make sure that it passes your general coding standards and your coding styles and these things. When a human actually looks at it, ask questions like, why do we need it? Is it maintainable in 6 months? If I come to the same code that I have written in after 8 months, which will be alien to me, of course, but can I still make sense out of it? If your answer is yes to these things, that's basically maintainable code.
So in terms of code reviews, what do you think? Like, so you covered a little bit about that in like the first time you explained that, but can you please clarify like what actually code reviews should be? Like, is it something like blaming each other, like say, hey, no, that's not the answer, right? But like, how should a code review be done? Like, it's just a safety net that say like, hey, if this code goes to production, like, does it blow up? Or like, let's say like we look into like small details of how the code is written and everything. Like, what should a code review be like?
Oh yeah, let me like ask you a different question along the same lines. Okay, you have two open pull requests, merge requests, whatever you want to call them. One has like 1,000 lines of change, all in like 50 files or so, and the other one is 20 lines of change in 3 files. Which one would you review first?
I'll review the 20 lines changes.
Exactly. So this is where code review and all of this process is a bit convoluted. People, I don't know, I don't remember the book, but there is a book which basically talks about flow. Like, the flow of work. And that's where I think I should have a couple of blog posts there as well. Basically, in a sitting, no one can comprehend more than 400 lines of code. Yeah. So if you start opening pull requests that's like 1,000 lines spread across 50 files, either people will like spend hours reviewing it, or they will just blind approve it. And the blind approval is where the issue is. So even before going into code reviews, the culture and the mindset that needs to change is we need to have smaller pull requests or like smaller commits. As soon as something works, commit it. Do you need a pull request? That's something that you need to think. That will depend upon the team. Just because you have a ticket, that does not equate to exactly one pull request. So thinking in this mentality automatically goes into making the software better, software engineering and the process itself better. For instance, let's give a bit of a concrete example, because this sounds a bit abstract. For instance, let's say you are working on a web application, and most, or if not all, most web applications, what they will have is they will have a controller where actually the code comes in and that just glues all of the other parts together with it. So unless you don't have that controller route, it's not going to glue with all of your code. So you could have 3 or 4 PRs that actually puts all of your code in production, but it's not really getting interfaced because there is no router. So if that enabler code, that router becomes the last thing in the as pull, let's say it's like the 4th or the 5th pull request, you're already doing an amazing job. But I don't think generally software engineers think like this. They, as far as my experience goes, is like, I have a ticket, I do it, I open like a 1,000-liner PR, and then I expect someone to review it. Yes, they might have like they might spend 2 hours to review it, but I don't know if someone will actually spend that time. So the trick here, or the mantra here is open smaller pull requests, but it takes practice. You need to think of, okay, how do I actually break it into smaller pull requests, and then smaller, and then small tasks. But yeah, that's one thing. And even in terms of that, the other thing is going into pull requests. How you review the code is, because it's smaller, then you have a tendency to go deeper and then look at all of the things that you need, not only naming and these things, actually trying to make sense, and it is small enough to fit in your head, and you give enough time to it. So that's how I look at pull requests and code reviews.
Okay, thank you very much. So on that note, I believe that code that you write should be maintainable and testable, and the pull request should be smaller as much as possible, right? So that's the like way to summarize in a very small manner.
It should not be as small as possible. There is a balance. Like, it should be logically small.
Yeah, it should be a balance.
Not like, don't give me a pull request that 1,000 lines spread across 50 files, because I'm not going to review it, basically.
So we talked about code reviews and clean code and everything, but just from your experience, like, you have been someone who have been working in like microservice architecture and deploying solutions around it. So but in terms of microservices, usually there is a trend like we develop microservice that actually ends up being a monolith application, and engineers get confused on like what exactly needs to be done, and they follow bad practice or anything like that. So do you have an experience to share in terms of like how a microservice should be done, and like how to avoid making a monolith at the end, and like how exactly it needs to be done properly?
Sure, that's a very good question. So I think the first thing to analyze or think about is, do you even need a microservice? If you're just a small startup, the first thing you might want to think is, probably a monolith will get me across for at least a couple of years, and then I can think of breaking it down into microservice as per need. I think that's like the most basic thing that people at times tend to get wrong. Okay, let's say that you are already in business, the thing is making money. Now it's 2 or 3 years, your team has grown to around 10 people, and then now it makes sense to let's break our big monolith into microservices. For instance, I think even GitHub or all big companies still have that big that big monolith that they started with, right? So it's not an uncommon thing that when companies start, they start with a monolith and then later break it down. So along the same lines, yeah, like the first decision you need to make is, do we really need to go into microservices? That's number one. And then number two, let's say if you have decided to go into microservices, yes, read the books. Like they tell you lots of things. I have already worked in $2 million companies, if not $1 billion companies, that have had microservices. And in my previous job, we had like 150 microservices managed by 10, 12 backend engineers. So with that in mind, yes, do follow the books, do follow all the visionaries and what they tell about microservices, but then carve out what you can do, like in practice, what practically makes sense to your particular context, your particular situation, and your business. Because at the end, it's about the business making the money. Like, and if the business does not continue to make the money, you have microservice or monolith or SOA or whatever you want to have, that doesn't really make sense. It's at the end, like, does the business make enough money to pay my salary and have profits? Yes. Does microservices and having smaller teams and all of this fit and or aid to that goal? Yes. Then yeah, go into microservice. That's how I would say to think about it.
Okay. So in terms of microservices, there we also have a concept called feature flags. Usually we use that when when we need to dynamically enable a feature and close that, or maybe disable that as well, right? There's a lot of confusion around how it should be done, and do you actually need a third-party tool, or can we develop our own tool for that, or how in your experience, how have you been using the feature flags, and how it should be done as per your experience?
Sure. Yeah, just to add upon what you just said, microservices and feature flags can be looked into from different lenses, completely differently.
Mm-hmm.
So now going a bit into feature flags. For your question, do we need a third party or anything else to do it? I would say to start with, no. I remember my first feature flag, I think it was around 2013 that I was introduced to this idea of feature flags. I vividly remember that we were releasing PayPal, and my feature flag was, if email address is if email address is in this array, we had five people in the tech team. So if the logged in user's email address is within this five people that's in this array, then you get to see PayPal, else you don't get to see PayPal. And that's how my first microservice was deployed in production, and then that's how we tested PayPal in production back in 2013. It should be 12-13, and that basically changed my idea of, I can do this. This is an amazingly powerful technique, and it's basically a technique. It's not code. It's just a if else, if you think of it, right? So it's a very powerful technique. And yeah, that was, I said, 2012, so almost 10 years back. And now if I see of microservice, yes, there are multiple services like Flagsmith, like LaunchDarkly, and all of these. If you want, you could of course use them, but first get the taste of it. First find the need for it. For instance, as I said, if you are an e-commerce company and you're introducing a new payment gateway, yes, it's a lot better to have a feature flag first to say like a canary release of only 5 people, then to say okay, now it works for the 5 people on production. Let's go with 2% of the traffic, then 5% of traffic. Gradually you go into 100%. So that's one of the ways to use microservices. Feature flags. Other things are there also for experiments. If we have an experiment and then you want to put it behind a toggle or a feature flag, yeah, that's a possibility. In terms of the intersection between microservices and feature flags, as you mentioned, yes, that is also a possibility. For instance, what could happen is, let's say you have your product detail page. So sorry, my examples are going to be all e-commerce because I have worked in e-commerce for the past almost 9 years. Anyhow, coming back to the topic, if you are on a, let's say a product detail page, and it has recommended products, for instance, right? And that recommended products comes from a different microservice, but due to XYZ reasons, that recommendation microservice is down. So what you could have is, you could have a feature flag that says recommendation products on and off. Because my recommendation service is down, people should still be able to buy it, because showing or not showing recommendation is not part of the critical path. The critical path is, I find my products, I see my products, I add it to cart, then I check out. So not having recommendations is is fine with this flow. I can still check out and earn the money. And let's say my recommendation like gets it from a third party, I don't know, some Alibaba or some Google thing, and they are down because of XYZ reasons. Like even S3 was down for some hours some years back. So it's not given that Google can't be down for 1 hour. They can be, right? So because like my third party provider is down, I just turn off that toggle, and then my critical path still goes on. My business, like the business can still make money. So that is another good use of feature flags. There are multiple, but these 2 or 3 are like coming on top of my head.
Okay. So feature flag, it is something like does everyone needs to actually look into that? Because it seems like to me it's a very powerful thing that anyone can implement in, like whether it's a monolith application or the microservice architecture or whatever it is, right? So do you think like it should be a first thing to do in terms of like adding features or anything, like so that we don't run into issues in production or something like that?
Yeah, I'd say three things there. First is it's a trade-off. It's complexity that you are adding in the code. So make like tickets or whatever. Make a note that you'll need to remove it in future. Because for instance, the same example with that payment gateway. Once it's 100% for 2 weeks. That means it's fine. That there are no bugs or anything left. And at that point, that particular flag has to be removed. That's like the first thing that comes with feature flags, because it's not free lunch, right? So that's one thing.
So I was just saying that like when you're writing a new feature or anything that's not that hasn't been done before in the application, and like should we just start writing feature flags for that, or like is it something that we should consider doing it or not?
Generally no, but one thing that I would consider is, can I ship it safely? What's the risk? As soon as there is like a good amount of a good percent of risk, it's advisable to keep it behind a feature flag. There is a term called blast radius. I think it comes from the book Accelerate. So basically, if I introduce a payment gateway and I put it to 100% of my customers and it breaks, that means I don't earn nothing till the time it breaks. If it breaks for 15 minutes, probably I'm losing thousands. Or if you are Amazon, you're losing millions of dollars in that 15 minutes. Can you afford that? If the answer is no, then yes, put it under feature flag. If it breaks, you don't need to redeploy anything. You just go somewhere, click a button, and then it works. Like the general sense of feature flags. So yes, I think these would be the factors that I would consider: risk and risk and shipping with confidence. And like there is a way that you can test something on production with having your blast radius to, for instance, 2 people, which is you and another teammate, which is a risk which you can easily take. So yeah, these are the kinds of things that would influence a decision of having a feature flag. But the caveat here is, yes, they add that extra layer of complexity. And is your team willing to take it and pay it later when you don't need that feature flag? So that's another thing that you should really consider.
So that's a very good explanation on in terms of blast radius. So I think that particular concept applies in most of the things. Even if do you think like that even applies for the code review part? Because if this code review and everything doesn't go well, like or like isn't done well, like the impact that it can make in the code review, like if that code goes to production, could be smaller or bigger, right? So like how does that come in the code review side as well? Like
that's a nice question. What I would think, and I would not argue, but I would put another light on this topic is, do you even need code reviews? Because if you talk about something, if you know about, or if the audience or whoever is listening to this is aware of a thing called trunk-based development, which is basically everyone pushes to master. You don't really have code reviews because everyone pushes to master. But how is that possible? It's possible because every line of code is pair programmed. That means another person is sitting besides you, and then the code is being reviewed as soon as it is being written. So every line being written is just like synchronously, almost in real time, being reviewed. So that's another way of looking at it. So code review is there, yes, that helps, but code review is also another complexity in the process. What I generally say is an open pull request or a merge request is a liability in at least 2 ways. One, it's a feature that has not gone live. Two, as longer the pull request remains open, the chance of getting merge conflicts and these things become higher. So even code reviews, yes, it has all of its good aspects. I'm not saying it is good, but playing like the devil's advocate, does it slow down the team? Like, again, going back to the flow thing that I was mentioning earlier, does it slow down the team? So yeah, exactly, these are like all of the trade-offs that you need to know about from a team point of view, and then take the right trade-offs that make the most sense to your team and the context.
Okay, thank you very much for that insight as well. I'd like to move into another like topic that's more of a career side. You have been working in this industry for like last 10 years, and like you are still very technical in terms of like the job responsibility that you do, and like the day-to-day tasks that you do, right? But usually what happens is like whenever you work like for like 6-7 years, like people tend to, there is a tendency that they start going to a managerial position, and like how is it, like how are you able to keep up with the tech, and why haven't you like switched to a managerial position, like still in a very technical heavy position right now?
Thank you for the question. So let's track back like 9 or 10 months when I became a lead software engineer. So basically I was also facing that I was facing that glass ceiling of being a senior software engineer for almost 7, 8 or 10 years, something of that sort, right? So that I think that basically also answers your question, that I was a senior for almost 7, 8 or 9 years, something like that. Because when I was in Nepal, I was a senior. When I joined Namshi in the UAE, I joined in as a senior developer. Even here, when I came in 2018, I joined in as a senior developer. So that is one of the reasons that I have been technical, and it's just been less than a year that I've been a lead software engineer. That's part one of the story. Part two of the story is what we need to understand is in bigger companies, at least in the FANG world, like Facebook, Apple, and Google, what happens is there are two kind of parallel tracks. One is called the IC, the individual contributor track, where someone becomes software engineer, senior software engineer, lead, staff, distinguished, principal, blah 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 blah, that part. So here you don't have any reports coming to you. You are not a manager, but you have influence, but you don't have authority. So this is like the individual contributor path. Then you have the other path where you go from software engineer, senior software engineer, engineering manager, senior engineering manager, VP of technology, CTO, and basically this is the engineering path. Sorry, this is the manager path, where you become manager, then you become a senior manager, like a manager, and then something like a CX role. I like to be on the individual contributor path because, one, I want to stay very technical, and probably you said it yourself, like after 6 or 7 years you kind of shift into this manager position. But I don't think it's a shift, it's a career change. It's not a promotion, it's a career change. You are not going from technical to another higher technical level. You're going from a technical person to a manager, which is a completely different thing. If you ask me why, systems, like the left IC part, is systems are easy. By that I mean systems are either 0 or 1, works or doesn't work. Like your code either works or doesn't work.
Yeah.
Like your microservice works or doesn't work. People are not 0 or 1. People have a very long shade of gray. Like there is white and there is black, and there is a long shade of gray that you cannot control. One, and then two, every individual is different. And I think from at least at this point in time of my career and from my personality traits, I'm not very well carved for this manager position at this point in time. I might have a different answer within 1 or 2 years. I don't know. But at this point in time, even after working as a software engineer for 14-15 years, at this point in time, I am not carved for this. Yes, I have some of it. I have like some of the mentoring qualities and everything. But probably I would not be very, very comfortable having a chat with someone about their remuneration and their raise and things like that, right? So yeah, exactly. But these are the kinds of skills that you can build. But the first like basic thing that you need, like two basic things that you need to understand is systems, 0 and 1, works or doesn't work. People, it's not works or doesn't work. Like someone might have a fight with their wife, and that comes and then affects their work. So that's not 0 and 1, right? That's the first thing. Yeah. And Yeah, and the second thing is that you really need to understand that you actually have these two tracks, the IC track and the managerial track. And yes, like managing people is, yeah, like, sorry, the second thing is managing people is not a promotion. You're not becoming more technical. It's a career change. You're going from a software engineer to a manager. So yeah, you as in yourself need to decide, if you are being pushed into being a manager in 6-7 years. Yeah, I don't know, probably you might want to look for a new job, or like think of it, that you actually want to do it or not. That would be my take on it.
Yeah. So whatever you say about like it's not a promotion, it's a career change, that really blew my mind, because I thought it was always a promotion.
Sorry, just to add up on it. I listen to like multiple podcasts, and yes, this was, yeah, very well articulated by one of the people who has tried both things. Like the person became a lead engineer, then became manager, and then actually come back to IC track again after like a year or something. And he very well articulated that it's not a linear promotion, it's a career change. You are changing both. Anyways, go ahead.
So we are hopping around like different tracks, like tracks and of the career, like, so it's a career change at the end. All right, thank you. It's on that. So the other thing that I wanted to cover is like when you were like a very when you're just starting your career in the tech, and like probably it's around 2010 or 2000, around, it was around that time, and like what were the things that you thought like you would know, it would have been better to know back then, like after all this experience that you have gained, so that this particular takeaway could be help upcoming engineers and aspiring software engineers in the field.
Yeah, sure. Yeah, so I finished my bachelor's in around 2007, and that's from then that I have been working full time in software engineering, except for a year when I did my master's. So that's around when I started. Yeah, and yeah, I started even from my internship itself. I think my internship in 2006 was paid, but I don't remember. Let's not go there. So the points that we are making here is what, as a junior software engineer, you knew would have been better. So yeah, within this 14-15 year journey, the basic like things that I wish junior software engineers would know is basically, the first thing would be business acumen. How the hell does the business make money? That's like the first thing that you need to know. From what I understand is, business makes money with two things: either you add value to the customer or you save the cost. Yeah, as soon as you think of it, every person in the organization is basically working in like switching these two levers here and there. So that's like one of the first things that you need to understand. So along the same lines, what you need to do is you need to look into yourself as a solution provider. So the business is trying to make money, and then my solutions add up so that the business can make more money, because unless you are working for a not-for-profit or a government, it's basically you're working for a profit, and by profit it means how much money does the business make, how much profit does the business make. So with all of this in mind, now connecting the dots, all of this fights about language A versus language B, spaces versus tabs, and all of that very, very fast become irrelevant, completely irrelevant. Yes, if you want to get into those irrelevant battles, be my guest. But then I would ask, like, does it add $1,000 to the business's revenue or not? If the question is no, then let's not go into there. That's one of the things. The other thing would be, like, don't get married to a language or a framework. That doesn't really help. Expand your horizon. Like, just because JavaScript is amazing now doesn't mean in 5 years it will still have that place. For instance, when I started using Angular in 2013, that was the best thing ever in 2013 when Angular came out. Google released like a JavaScript framework, and look at it now. It's completely probably thrashed by React in just 5 or 6 years. So that's what I'm saying. Like, don't get married or don't religiously follow any language or a framework. You don't know. No one knows the future. So yeah, like those would be the two major things. Of course, the other thing would be like think of the abstractions. Be very strong in your basics. For instance, I don't know when HTTP was written. Probably it was written like 25 years back, but it still works. HTTP 1.xx is still like the main thing. So try to write that kind of software which stands the test of time. Like try to do those kinds of things. Don't go into too much of abstractions. For instance, using an ORM might feel that it's very easy. It makes writing. I don't need to write SQL queries. I can even change the database. Wow, that's amazing. But just look at it and just dig a bit deeper, and then you'll find out that to do that trade-off, it's making a lot of performance. It creates a lot of performance issues and these things. So the main thing is like be very strong in your basics. As long as you're strong in your basics. For instance, for a web developer, if you know how HTTP works, that's like a very basic thing. And if you are into backend, for instance, how generally databases work, like what's an index, like what it does, that is a lot better knowledge to grab and gain than learning the latest ORM or I don't know, like all of these extra layers and abstracts that are on top of it. Go one level deeper and try to get the basics correct. That's gonna take you a lot further.
Yeah, so I think on that note, like when you know the basics better, like it also helps you not to marry a particular frameworks and language, because you can hop around into multiple technologies and frameworks because the base concept is the same. So I usually talk about this a lot as well. So, but the other side also wanted to cover on was like mentoring and coaching. Like you recently mentioned that you had a mentor and like you are working closely with him, and like how this like in terms of techno, like being a software engineer and being in tech, like how does this mentoring and coaching work, and where do I find mentors and coaches? Like what's your experience around it?
That's another amazing question. So in terms of mentoring and coaching, it's a two-way street for me. By that I mean I don't have any official mentees as such, but yeah, there are many people who come to me for career advice, for other things. I am also doing like a side project that's called AU Tech Jobs, which basically tries to get people who are here in Australia, basically tech students who are not really doing full-time tech jobs, just tries to get them into full-time tech jobs, which is to an extent life-changing. So that's one part of it. Yeah, and then yeah, that like as I said, like no one is like my official mentee as such, but yes, that's something that I do. If someone approaches me for being a mentor, yeah, I think I would generally say yes, depending upon my time availability. And yes, that's how I have mentored people. That's one thing. And even within the organization, like I have again nothing formal, generally casually, but mentored people to step up from like software engineer to senior software engineer or above. There are multiple things within that. So yeah, mentoring and coaching is something I like to do. And about finding mentors, so if you are willing to pay some money, I think there is a website called Mentor Cruise. If you want, you could just go there and browse through people and then see, okay, this person kind of fits my needs of being a mentor, and then I could get that. That's one way of trying to find a mentor. But the other way that I would think is much more effective than going to basically they are a complete stranger and you are approaching them. Rather than that, what I would say and what I have done now is I just went to one of my old managers. To be honest, like even in 15 years, I just had like 4 or 5 jobs. So I didn't hop jobs much. And at this point, because I thought I needed a mentor, what I did was I went to one of my old managers and I just said, yeah, I'm looking for a mentor. Would you be able to spare 30 minutes every month? And he said yes, thankfully. And that was it. And then now we kind of have our one-on-ones every week or every 2 weeks, depending upon his and my time and time zone. So that's how I look at finding mentors, and I think that's a good strategy to take. Yeah, but I think having a mentor, especially having someone who has already gone through what you are going through now, that helps very much. And if that person has already worked with you in the past, you already have that connection to that person, understands how you work, understands your wavelength and everything. So that's, I think, a good and let's say if they were a manager or even one level higher than you, one or two levels higher than you, that means that even after 2 years they would be 1 or 2 levels higher than you even at this point, right? So that actually helps you to see that picture and try to get that mentor who has already done that. And that's how I would see that you should approach mentoring.
Yeah. So on that side, like, do you think like professors that have taught you in like college and universities would be a good mentor for you as well, because they know you in and out, right?
I with all due respect, especially like the professors or like the teachers in Nepal, I would not be very comfortable having them as a mentor. Like the first point of discomfort would be because most of them were not practitioners. As I said, with all due respect, all the people who taught us software engineering, like one of them was someone who just passed out 1 or 2 years before us, so that person hardly had any hands-on real software engineering experience. That person hadn't written a real production software. Probably in my 4 years of bachelor's, I hardly met like 2 or 3 people who had actually written software in their life and had like deployed, had actual clients, or had worked in software. So that's the reason I would say that I would not really be very comfortable, because what I'm looking for a mentor is someone who has gone through where I am right now, like a year or 2 or even 3 or 5 years back, and they can help me with my current situation. Because generally mentorship and coaching, even for junior or like software engineers, would be much more people level skills than hard technical skills. For instance, I want to learn React, buy a course of like $100, $200 somewhere, spend all of your time. It's lockdown times right now, give all of your weekend to that, you can learn it. Like I don't think that's that difficult. Mentorship and coaching should be focused more on the people side of things, on the soft skills. They say soft skills, I say people skills, whatever you want to call them, and very specific to your situation and where you want to get. So probably mentoring is like, okay, I want to get here, I am stuck into these things within my current context, how do I untie the knots and then climb up the ladder? I think that's, if your mentoring is focused on that, it's better than saying, I want to learn React, I want to learn Stealth, whatever XYZ, I want to learn Java Spring, can you teach me Java Spring? Just Google it, man. You'll find 20 videos that will teach you. Don't find a mentor for it.
Yeah. So with that, so thank you very much on like covering the topic on mentoring and coaching as well. So but that really doesn't mean professors and teachers are not the person to look into, but just look into someone who has been more into practical stuff.
Exactly.
So
that's where my point is. Yeah. Sorry. If you want to become a professor, find a professor who can be your mentor. If you want to become a better software engineer, find a software engineer who can be your mentor. As straightforward as that, right? And as I said, with all due respect to all of the people who have surely taught me lots of stuff in life.
Yeah, thank you very much. And so with that, we'd like to end this episode. We covered topics around like being a lead software engineer and like microservices, feature flags, also like code reviews and like different philosophies around it. So thank you very much, Geshan, for like being with us and like sharing your experience and the things that you have learned working like over a decade. Do you have any like ending notes and like that you want to share to the audience, and so that they can take the most out of this episode, and like how they can improve as a software engineer in their career as well?
Yeah. So yeah, some of the things that come to my mind is don't limit yourself, one, and especially in this context where COVID has basically pushed us some years back, as well as pulled us out some years back in terms of using not using cash and using cards, e-commerce as well as remote work. So expand your horizon. Don't just look for work within your city or your country at this point. Try something. Probably there are lots of remote work websites, and people have actually become very, very open to hiring people anywhere in the world, as long as you have a reliable, good internet connection. I think you could possibly be working for any company, like many companies that allow remote work. Of course, you'll need the skill. So yeah, focus on that. Again, going back to the same thing, be very strong in your basics. Like learn what basics do you need for your part of the job. If you want to be a front-end engineer, that might be a bit different than if you want to be a back-end engineer or a DevOps or a SRE engineer. So learn your basics very well. I think these are the things that will help. And like consume the resources, or like consume the things that you get very selectively, because it's a era of information overload. As I said, if you go to Google and search for something, you'll find a lot of things, but the thing is, like, you cannot read all of those things. You need to read a very curated list of. That's why go on with recommendations. Ask someone. That's why you need a mentor who can say, okay, if you want to be better at this, read this and this, because he has already done that research, went through 20 things, and then is giving you like the 3 good things that actually have worked for him. So that curation and that selection is what is important, I think, in this day and age. Yeah, I think that's mostly it.
Okay, thank you very much for your ending note. So with that, we'd like to end this episode, and I will be coming back with a new guest with next week. Until then, have a great time. Bye-bye.